Sustainable sugarcane farming is a vital component of agricultural practices aimed at achieving long-term productivity, environmental conservation, and economic viability. To support farmers in their pursuit of sustainable sugarcane cultivation, Cuba Soil Conditioner offers valuable information and effective solutions across a range of critical subjects. Covering the following topics: overview of sugarcane as a crop, climatic conditions, soil conditions, soil preparation and fertility management, seed selection, spacing, crop nutrient management and fertilization techniques, various fertilizers, inorganic, organic and mineral-based fertilizer, natural sources of phosphates, natural source of nitrogen, cow-based fertilizers, Cuba Soil Conditioner, products, content and activity, a thriving soil ecosystem, root development, growth of sugarcane stems, benefits of sustained release mechanism, leaf health, optimizing tiller density in sugarcane farming for maximum yields and biodiversity, overwatering, climate variations, the vital role of healthy soil in mitigating the effects of water shortage or drought conditions, hot climatic condition, cold weather condition, sugarcane disease prevention and control measures, insect prevention and control measures, the impact of sugar levels on sugarcane growth and health, enhancing biodiversity in sugarcane farming with companion plants, sugarcane growth cycle. By incorporating the insights and solutions provided by Cuba Soil Conditioner, farmers can maximize their yields, improve soil health, and contribute to the long-term viability of sugarcane farming. Overview of sugarcane as a crop. Sugarcane Saccharum officinarum is a perennial grass crop known for its high sugar content. It is widely cultivated in tropical and subtropical regions around the world, including South India. Sugarcane belongs to the family Poaceae and is primarily grown for the production of sugar, but it has various other uses as well. The crop has tall, thick, jointed stalks that contain a sweet juice, which is processed to extract sugar. Sugarcane is a C4 plant, meaning it has a unique carbon fixation pathway that allows it to efficiently convert sunlight into energy and grow rapidly. It requires a long growing season to reach maturity, usually ranging from 10 to 24 months, depending on the variety and climatic conditions. Types of sugarcane suitable for organic farming. When it comes to organic farming, choosing the right varieties of sugarcane is crucial. Here are some sugarcane varieties suitable for organic cultivation. Colorado 86032, this variety is well adapted to organic farming practices. It has good cane yield, high sugar content, and exhibits good resistance against pests and diseases. Colorado 94012, known for its organic farming suitability, this variety is resistant to waterlogging and shows tolerance to drought. It has good yield potential and excellent retunability. CO 118, this variety is suitable for organic farming due to its resistance to pests and diseases. It has good sugar recovery and can perform well under organic management practices. Colorado 05011, it is a high-yielding variety with good retuning ability. It is known for its tolerance to water stress and shows resistance to common sugarcane diseases. It's important to note that the availability of sugarcane varieties suitable for organic farming may vary based on the specific region and local agricultural practices. Consulting local agricultural extension services or organic farming experts in South India would provide more accurate and up-to-date information on the best varieties for organic sugarcane cultivation. Climatic conditions. Rainfall. Sugarcane is a water-intensive crop and requires adequate rainfall or irrigation. The ideal rainfall for sugarcane cultivation is between 1,000 to 1,539 inches to 59 inches annually. However, sugarcane can tolerate both higher and lower rainfall conditions depending on the variety and growth stage. Regular and well-distributed rainfall throughout the growing season is important, especially during germination, tillering, and sugar accumulation stages. In areas with lower rainfall, Supplementary irrigation is necessary. Sunshine. Sugarcane requires abundant sunshine for optimal growth and sugar accumulation. It needs around 6 to 8 hours of direct sunlight daily. Temperature. The optimal temperature for sugarcane growth is around 25 to 30 degrees centigrade during the active growth phase. Cooler temperatures can slow down growth, while excessively high temperatures can affect the crop's health and yield. Soil conditions. Soil texture. Sugarcane prefers well-drained soils with good water-holding capacity. Sandy loam, and clay loam soils are considered suitable. Excessive clay content or heavy soils can cause waterlogging and affect root development. Soil pH. The ideal pH range for sugarcane cultivation is between 5.5 and 8. However, sugarcane can tolerate a slightly wider pH range depending on the variety and soil fertility management practices. A fertile soil with a diverse population of fungi and bacteria can naturally balance the pH, so nourishing the lands with ample soil life is important. Soil preparation and fertility management. Land preparation. Prepare the land by plowing and harrowing to remove weeds, loosen the soil, and facilitate good root penetration. Proper land leveling helps in uniform water distribution during irrigation. Organic matter. Incorporating organic matter, such as well-decomposed farmyard manure or compost, improves soil structure, enhances water holding capacity, and adds essential nutrients. Additionally, utilizing the uncultivated period or between repeated growing of sugarcane by seeding your farms with various monocot, dicot, and oil seeds can help regenerate the soil. Allow these plants to grow and then mulch them back into the soil between the 45th and 50th day, before flowering. This practice provides diversity and natural green manure to your farms. Fertilizer application. Apply fertilizers to meet the crop's nutrient requirements. Nitrogen N, phosphorus P, and potassium K are the primary macronutrients needed by sugarcane. Micronutrients like zinc Zn, iron Fe, manganese Mn, and copper Cu may also be required. In addition, incorporating products like Cuba Soil Conditioner and Cuba Soil Booster can provide all the essential micro and macronutrients required for sugarcane farming, enhancing soil fertility. Cow-based products. Incorporating cow-based products such as Jivamruth and Gochrapamruth can further enhance soil health. These products, derived from cow dung and cow urine, contain beneficial microorganisms and nutrients that contribute to the overall fertility and vitality of the soil. Applying Jivamruth and Gochrapamruth as organic fertilizers can improve soil structure, nutrient availability, and microbial activity, ultimately benefiting the growth and development of sugarcane plants. Crop rotation and green manuring. Practice crop rotation with leguminous crops to fix atmospheric nitrogen and improve soil fertility. Green manuring, such as planting cover crops like cowpea or sunhemp, helps add organic matter and nutrients to the soil. Regenerating soil before plantation. We also recommend utilizing the uncultivated period by seeding your farms with various monocot, dicot, and oil seeds. You can sow 3 kilograms of each type of seed and an additional 5 kilograms of different seeds. Allow these plants to grow and then mulch them back into the soil between the 45th and 50th day, before flowering. This practice provides diversity and natural green manure to your farms, enriching the soil and promoting overall soil health, which also deters invasive plants. Furthermore, we recommend incorporating cow-based products such as Jivamruth and Gochrapamruth to further enhance the soil health. These products, derived from cow dung and cow urine, contain beneficial microorganisms and nutrients that contribute to the overall fertility and vitality of the soil. Applying Jivamruth and Gochrapamruth as organic fertilizers can improve soil structure, nutrient availability, and microbial activity, ultimately benefiting the growth and development of sugarcane plants. By incorporating diverse plant species during the uncultivated period and utilizing cow-based products like Jivamruth and Gochrapamruth, sugarcane farmers can enhance soil fertility, promote biodiversity, and foster sustainable farming practices. These practices contribute to healthier crops, better weed suppression, and improved overall farm productivity. Please note that specific soil and fertility management practices may vary based on the region, soil type, and local agricultural practices. Seed selection is a critical aspect of sugarcane cultivation, and there are two main methods for obtaining planting material: tissue culture seed and conventional seed. Benefits of tissue culture sugarcane seed. Disease-free plants. Tissue culture produces healthy and disease-free seedlings. Through micropropagation in a controlled, sterile environment, the risk of transmitting diseases and pests to the field is minimized, providing a clean start for sugarcane cultivation. Genetic purity. Tissue culture allows for the production of genetically uniform plants. Each plantlet is derived from a single cell or tissue, ensuring identical genetic characteristics, which is advantageous for maintaining desired traits and variety purity in sugarcane. Rapid multiplication. Tissue culture enables rapid multiplication of plants. A single tissue culture plantlet can be multiplied into hundreds or even thousands of identical plants in a short period, ensuring an abundant supply of seedlings for commercial cultivation. Early harvesting. Tissue culture plants generally exhibit faster growth rates and earlier maturity compared to conventional plants. This accelerates the harvesting process and leads to quicker returns on investment for sugarcane growers. Controlled adaptation. Tissue culture plants can be acclimatized to specific field conditions gradually. They are subjected to controlled stress conditions before being transferred to the field, reducing transplant shock and improving survival rates during establishment. Selection of suitable nodes for conventional sugarcane seeds. In conventional sugarcane propagation, mature stalks with well-developed buds or nodes are used as planting material. The selection of appropriate nodes is crucial for successful seed production. Generally, the lower nodes on the sugarcane stalk are preferred for seed production due to the following reasons. Bud viability. Lower nodes typically have more viable buds compared to the upper nodes, increasing the potential for germination and healthy plant growth. Nutrient reserve. Lower nodes tend to store higher nutrient reserves, providing energy and nutrients to support initial growth and establishment of the planted seeds. Disease resistance. Lower nodes are less exposed to diseases and pests, reducing the risk of transmitting pathogens to the new plants. Shoot emergence. Lower nodes have a higher likelihood of successful sprouting and shoot emergence, ensuring better establishment and growth of the planted seeds. Important. While selecting conventional sugarcane seeds, it is advisable to avoid using the bottommost 4 nodes and top 6 nodes. The bottom nodes are closer to the ground, making them more susceptible to soil-borne diseases and contamination. The top nodes may have started to mature and could exhibit lower viability and growth potential. By excluding these nodes, sugarcane growers can focus on selecting intermediate nodes, which are more likely to have viable buds, better nutrient reserves, and higher potential for successful growth. It's essential to choose healthy, disease-free stalks with well-developed buds from mature sugarcane plants for conventional seed production. Proper handling, treatment, and storage of the selected stalks are crucial to maintain seed quality and viability, contributing to better crop establishment, growth, and yield. For precise recommendations tailored to specific regions and varieties, factors such as sloping terrain, waterlogging issues, soil type, and other regional realities need to be taken into account. It is advisable to seek guidance from local agricultural extension services or sugarcane experts who are familiar with the ground realities of the specific region. They can provide valuable insights on the appropriate direction of the rows, considering factors like terrain, water drainage, and variety characteristics. Spacing. To avoid disease and insect infestation and ensure optimal sunlight and air circulation for sugarcane growth, it is important to provide adequate spacing between plants. The recommended spacing may vary depending on factors such as climate, variety, and management practices. Here are some general recommendations for spacing in sugarcane farming. Row spacing. Maintain a minimum row spacing of 1.2 to 1.5 meters 4 to 5 feet between the rows. This spacing allows for proper movement, accessibility, and management of the crop. It also helps to prevent the spread of diseases and pests from one row to another. Intra-row spacing. For the individual plants within each row, a spacing of 60 to 90 centimeters 2 to 3 feet is commonly recommended. This spacing provides sufficient room for the sugarcane plants to grow without overcrowding. It allows sunlight to penetrate the canopy and facilitates good air circulation, reducing the risk of disease development. Stool spacing. In the stool planting method, where sugarcane stalks are harvested and left in the ground for regrowth, maintain a minimum spacing of 60 to 90 centimeters 2 to 3 feet between individual stools. This spacing ensures that each stool has enough space to grow and develop properly, reducing competition for nutrients and minimizing the risk of disease transmission. By providing adequate spacing, you allow for proper light penetration and air movement within the sugarcane plantation. This helps in reducing humidity levels, drying foliage faster after rainfall, and preventing the buildup of moisture, which can contribute to disease development. Sufficient spacing also makes it easier to monitor the crop for pest and disease infestations, facilitating timely interventions if necessary. It's important to note that these are general recommendations, and local conditions and specific varieties may require adjustments in spacing. Consulting with local agricultural experts or experienced sugarcane farmers in your region can provide more precise recommendations based on the specific requirements and conditions of your sugarcane cultivation area. Crop nutrient management and fertilization techniques. Sugarcane farmers are advised to apply fertilizers from the seeding day and limit the fertilization period within 90 days, with the recommendation to stop fertilizing after 120 days. This approach is based on the specific nutrient requirements and growth stages of sugarcane crops. During the early stages of sugarcane growth, the focus is on establishing a strong root system and promoting vigorous shoot growth. Applying fertilizers during this period provides the necessary nutrients for healthy root and shoot development. Sugarcane has a high nutrient demand, especially for nitrogen N, phosphorus P, and potassium K. Applying fertilizers within the first 90 days ensures an adequate supply of these essential nutrients during critical growth stages, supporting robust vegetative growth, tillering, and canopy development. Sugarcane plants have a higher capacity to take up nutrients during the initial growth stages. By supplying fertilizers within the first 90 days, farmers maximize nutrient uptake and utilization, promoting optimal growth, biomass accumulation, and sugar yield potential. Applying fertilizers throughout the entire growth cycle can lead to nutrient imbalances and potential environmental pollution. Limiting the fertilization period to 90 days helps maintain a balanced nutrient supply, preventing excessive nutrient accumulation in the soil. As sugarcane approaches maturation and ripening after around 120 days, the focus shifts to sugar accumulation in the stalks. Continued vegetative growth stimulated by fertilizers after 120 days may divert resources away from sugar accumulation, resulting in lower sugar content and reduced crop quality. Using fertilizers after 120 days may not be cost-effective. The additional yield achieved through late-stage fertilization might not justify the extra expenses incurred, lowering profitability as the crop nears maturity. Late-stage fertilization can lead to environmental concerns, such as nutrient runoff and pollution. It is important to balance nutrient application to minimize environmental degradation and adhere to sustainable farming practices. Late-stage fertilization may increase the risk of lodging, making the crop more vulnerable to diseases and pests, reducing crop health and yield potential. Instead of late-stage fertilization, farmers should focus on nutrient management during the critical growth stages up to 120 days or better still before 90 days. Adequate fertilization during this period ensures optimal vegetative growth, tillering, and canopy development. Other practices like irrigation, weed control, and pest management should also be considered to support overall crop health and yield potential. The profitability of using fertilizers in sugarcane cultivation depends on factors like soil fertility, crop variety, climate conditions, and farm management practices. Farmers should adopt a balanced and sustainable approach to nutrient management, considering the specific requirements of their region and crop. Regular soil testing and consulting with agricultural experts can provide valuable guidance for fertilization and other agronomic practices. Fertilizers. Use of urea and DAP fertilizers in sugarcane farming. Contents. DAP diammonium phosphate is a fertilizer primarily composed of nitrogen 18% and phosphorus 6%. Urea, another commonly used nitrogen-based fertilizer, has a high nitrogen content and dissolves quickly in water, making it readily available for plant uptake. Upon application, urea undergoes hydrolysis, converting into ammonium and then nitrate through soil bacteria. This process typically occurs within a few days to a week. Urea provides plants with an accessible nitrogen source, supporting their growth. However, factors like excess water or heavy rainfall can affect its efficiency. Both DAP and urea fertilizers lack essential components like organic matter and micronutrients necessary for maintaining soil health, structure, and microbial diversity. Neglecting these aspects can result in soil degradation and decreased long-term productivity. Direct contact between DAP diammonium phosphate or urea and sugarcane plant tissues, such as leaves, stems, or roots, and its effects. Both fertilizers have high nitrogen content, which can cause leaf burn, stem and root damage, nutrient imbalances, reduced nutrient uptake, and stunted growth, ultimately leading to decreased yields. To mitigate these issues, proper fertilization practices should be followed, ensuring that the fertilizers are not in direct contact with the plants and are instead applied to the soil for optimal nutrient absorption. Soil acidification. Improper application of DAP and urea fertilizers without incorporating them into the soil can lead to soil acidification, which negatively impacts soil microbial activity, nutrient availability, and overall soil health. Soil acidification occurs over time due to repeated fertilizer application, resulting in imbalanced pH levels and hindered nutrient cycling. This process reduces organic matter decomposition and disease suppression, compromising soil fertility. Acidic soil also limits the availability of essential elements like phosphorus, calcium, and magnesium, leading to nutrient deficiencies in sugarcane. Moreover, it increases the release of toxic substances such as aluminum and manganese, further impairing root growth and nutrient uptake. Soil acidification negatively affects beneficial microbial activity, soil structure, water infiltration, and long-term soil health. To prevent soil acidification, it is crucial to monitor and manage soil pH levels, consider crop nutrient requirements, and implement appropriate soil management practices. Nutrient loss, nitrogen volatilization, inefficient nutrient utilization, nutrient imbalances, and hindered plant growth. Neglecting to incorporate the fertilizers into the soil can result in inefficient nutrient release and uptake, while failing to adequately water them can cause fertilizer burn and damage to plant tissues and even death of plant. It is crucial to follow proper fertilization practices, including proper soil incorporation and adequate watering, to ensure optimal nutrient absorption, prevent nutrient imbalances. Unbalanced use of urea and DAP fertilizers in sugarcane farming can lead to nutrient imbalances in the soil, particularly focusing solely on nitrogen and phosphorus while neglecting other essential elements. This imbalance can negatively impact crop health, resulting in reduced yields and lower quality sugarcane. Excessive phosphorus levels from DAP fertilizers can hinder the availability and uptake of micronutrients, leading to micronutrient deficiencies despite their presence in the soil. Plant natural defense mechanism, excessive nitrogen, which promotes rapid vegetative growth, can prevent the development of the plant's self-immune response system and attract pests, leading to potential outbreaks. Imbalances in nutrient levels further compromise plant immune responses, making them more vulnerable to diseases. To mitigate these risks, it is crucial to maintain a proper nutrient balance and implement integrated pest management strategies. Excessive phosphorus levels resulting from improper application of fertilizers like urea and DAP can inhibit root growth and development in sugarcane plants. This restricts their access to water and nutrients in the soil, leading to reduced efficiency in nutrient and water uptake. The compromised root development also makes the plants more susceptible to stress conditions such as drought or nutrient deficiencies, increasing the risk of crop failure. Additionally, the weakened root system makes the sugarcane plants more prone to being toppled by winds. Uncontrolled flooding or heavy rainfall can have negative effects on the effectiveness and availability of nutrients, specifically phosphorus, from both DAP and urea fertilizers. Waterlogging can create anaerobic soil conditions that impact nutrient availability and plant growth. These conditions alter the release of phosphorus from both DAP and urea, affecting overall nutrient uptake and resulting in suboptimal crop performance. To mitigate these effects, proper drainage and management strategies should be implemented to prevent or minimize the impact of flooding and waterlogging. Improper use of DAP and urea fertilizers can contribute to environmental pollution. Excess nutrients can leach into groundwater or run off into water bodies, leading to nutrient pollution, degraded water quality, harmful algal blooms, and disruptions to aquatic ecosystems. The erratic supply of short-lived fertilizers like DAP and urea can negatively impact sugarcane farms, leading to nutrient deficiencies, imbalanced nutrient levels, reduced crop vigor, increased vulnerability to pests and diseases, inefficient nutrient utilization, and yield fluctuations. To address these issues, it is important to establish a reliable supply chain, plan properly, and implement sustainable soil fertility management practices. It is crucial to avoid direct contact between the fertilizers and plant tissues, incorporate them into the soil, and monitor nutrient levels to ensure optimal crop health. By adopting appropriate fertilization practices and sustainable soil management strategies, sugarcane farmers can promote long-term productivity and minimize environmental impact. Natural sources of phosphates. Phosphate rocks. Phosphate rocks are sedimentary deposits that contain high concentrations of phosphate minerals. These rocks are formed over millions of years from the accumulation of ancient marine organisms. Phosphate rocks are mined and processed to extract phosphate minerals, which can be used as a source of phosphorus for agricultural fertilizers. Guano. Guano refers to the excrement of seabirds and bats that accumulate over time in specific areas such as coastal cliffs and caves. Guano is rich in phosphorus due to the high phosphorus content in the diets of these animals. It can be collected and used as a natural fertilizer for agricultural purposes, including sugarcane farming. Organic matter. Organic matter, such as crop residues, animal manure, and compost, can contribute to the natural phosphorus content of the soil. As organic matter decomposes, it releases phosphorus in a form that can be taken up by plants. Incorporating organic matter into the soil through practices like cover cropping and organic amendments can help maintain and increase the phosphorus availability for sugarcane crops. Weathering of rocks. Over time, the natural weathering of rocks can release phosphorus into the soil. Rainfall, temperature fluctuations, and microbial activity contribute to the breakdown of minerals containing phosphorus, making it available for plant uptake. This slow release of phosphorus from weathering processes can provide a natural source of phosphorus for sugarcane farming. Natural source of nitrogen. Nitrogen fixation is a natural process that converts atmospheric nitrogen into usable forms for plants. There are two main ways this occurs: biological nitrogen fixation and atmospheric nitrogen fixation through lightning. Biological nitrogen fixation involves specific bacteria that form symbiotic relationships with certain plants, such as legumes and some non-leguminous plants. These bacteria convert atmospheric nitrogen into ammonium, which the plants can use for their growth and development. This process enriches the soil with available nitrogen. Atmospheric nitrogen fixation through lightning happens during thunderstorms. The high temperatures and energy generated by lightning cause nitrogen molecules in the air to break apart. The resulting nitrogen compounds dissolve in rainwater and fall to the ground as nitric acid. This nitric acid dissociates into nitrate ions in the soil, which can be absorbed by plant roots. While biological nitrogen fixation and the use of fertilizers are the primary sources of nitrogen for agriculture, lightning-induced atmospheric nitrogen fixation contributes to soil nitrogen levels, especially in areas with frequent thunderstorms. In summary, nitrogen fixation is a natural process that provides plants with a vital nutrient. Biological nitrogen fixation through symbiotic bacteria and atmospheric nitrogen fixation through lightning both play a role in enriching the soil with available nitrogen, supporting plant growth and agricultural productivity. Cow-based fertilizers. Cow dung. Organic matter. Cow dung is rich in organic matter, which provides nutrients and improves soil structure. Nutrients. It contains essential plant nutrients like nitrogen N, phosphorus P, and potassium K, along with trace elements such as calcium, magnesium, and sulfur. Microorganisms. Cow dung is a habitat for beneficial microorganisms like bacteria, fungi, and earthworms that contribute to soil health and nutrient cycling. Fiber. It contains cellulose and other fibrous materials that can enhance soil moisture holding capacity and promote microbial activity. Humus. Over time, cow dung decomposes to form humus, which further improves soil fertility, water retention, and nutrient availability. Cow urine. Nitrogen. Cow urine contains urea, a form of nitrogen that can be readily absorbed by plants. Minerals. It contains various minerals like potassium, phosphorus, calcium, and magnesium in small quantities. Organic compounds. Cow urine contains organic compounds like amino acids, enzymes, and hormones that can potentially benefit plant growth and development. Microbial metabolites. Urine also contains microbial metabolites produced by beneficial microorganisms present in the cow's digestive system, which can have positive effects on soil and plant health. It is important to note that the specific composition of cow dung and cow urine can vary depending on factors such as the cow's diet, health, and management practices. Furthermore, we recommend incorporating cow-based products such as Jivamruth and Gokrapamruth to further enhance the soil health. These products, derived from cow dung and cow urine, contain beneficial microorganisms and nutrients that contribute to the overall fertility and vitality of the soil. Applying Jivamruth and Gokrapamruth as organic fertilizers can improve soil structure, nutrient availability, and microbial activity, ultimately benefiting the growth and development of sugarcane plants. We also recommend utilizing the uncultivated period by seeding your farms with various monocot, dicot, and oil seeds. You can sow 3 kilograms of each type of seed and an additional 5 kilograms of different seeds. Allow these plants to grow and then mulch them back into the soil between the 45th and 50th day, before flowering. This practice provides diversity and natural green manure to your farms, enriching the soil and promoting overall soil health, which also deters invasive plants. By incorporating diverse plant species during the uncultivated period and utilizing cow-based products like Jivamruth and Gokrapamruth, sugarcane farmers can enhance soil fertility, promote biodiversity, and foster sustainable farming practices. These practices contribute to healthier crops, better weed suppression, and improved overall farm productivity. Kuba Soil Conditioner and Kuba Soil Booster are recommended for sugarcane farming to improve soil health and support the growth and development of sugarcane plants. These products can be used as part of regular cultivation practices. Additionally, Kuba Growth Promoter and Natural Horticulture Oil provide extra benefits for sugarcane plants. However, their use should be based on specific circumstances, such as previous disease or insect infestations and variations in climate. Kuba Growth Promoter enhances plant growth and boosts natural defense mechanisms against diseases like rust, while Natural Horticulture Oil helps manage insect pests, including the Eldana borer. These products are not always necessary and should be used selectively when needed. Natural Horticulture Oil is particularly suitable for organic sugarcane farming. To decide whether to use Kuba Growth Promoter or Natural Horticulture Oil, factors like pest or disease pressure, plant growth stage, and local climate conditions should be considered. Farmers should assess their specific requirements and seek advice from agricultural experts or extension services to determine the appropriate and effective use of these products in their sugarcane farming operations. For optimum results, Cuba Soil Conditioner and Cuba Soil Booster can be applied during sugarcane seeding or immediately after harvesting for ratoon crops. Cuba Soil Conditioner and Cuba Soil Booster. Cuba Soil Conditioner is an organic mineral-based fertilizer designed to be delivered through root application. It focuses on nutrient supplementation and improving soil health. The conditioner contains a range of essential macro and micronutrients, including phosphorus, potassium, calcium, magnesium, and other trace elements. It also contains humic acid, organic carbon, silicon, boron, manganese, iron, copper, amino acids, fulvic acid, sulfur, and nitrogen, phosphorus, and potassium bacteria. The primary goal of Cuba Soil Conditioner is to provide plants with the necessary nutrients for healthy growth and development. It enhances nutrient availability in the soil, promotes balanced nutrient uptake by the roots, and supports overall soil fertility. The conditioner also contributes to the improvement of soil structure, microbial activity, and nutrient cycling. Its mineral composition provides a large surface area per gram, maximizing nutrient absorption by plant roots. Additionally, its hygroscopic nature allows it to absorb moisture from the air, maintaining a cool environment and releasing water to plants as required. Cuba Soil Booster is a natural and organic soil amendment product designed for root application. Its primary purpose is to promote plant growth, improve soil health, and provide natural pest and disease control. The booster consists of a unique blend of ingredients, including neem azadirachta indica seed, organic carbon, bioagents like trichoderma, humic acid, amino acids, and seaweed extracts. The combination of these components works synergistically to enhance microbial activity in the soil, safeguard seeds, improve germination rates, protect roots from diseases, and stimulate root growth. The booster also helps improve nutrient uptake by plants, ensuring that essential elements are efficiently absorbed from the soil. Furthermore, it enhances plant tolerance to environmental stresses, such as drought or temperature fluctuations. Cuba Soil Booster acts as a natural and organic solution for promoting plant health and vitality. By improving soil quality and optimizing plant growth, it indirectly contributes to pest control by enhancing plant vigor and resistance. The booster is suitable for organic farming practices and can help farmers maintain the health and productivity of their crops in a sustainable manner. A thriving soil ecosystem. Microbial activity enhancement. Cuba products contain beneficial microorganisms like trichoderma, which can enhance microbial activity in the soil. These microorganisms play a vital role in breaking down organic matter, cycling nutrients, and promoting soil health. By introducing beneficial microbes, Cuba products help create a favorable environment for soil life to thrive, which indirectly supports the growth of sugarcane plants. Organic matter decomposition. Cuba Soil Conditioner is rich in organic carbon and humic acid. These organic components provide a food source for soil microorganisms, stimulating their activity and promoting the decomposition of organic matter in the soil. As organic matter decomposes, it releases nutrients in plant-available forms, enriching the soil and supporting the growth of sugarcane plants. Nutrient cycling. The presence of organic carbon and other nutrients in Cuba products encourages nutrient cycling in the soil. Beneficial soil microorganisms break down organic matter, releasing nutrients that become available for uptake by the sugarcane plant's roots. This cycling of nutrients improves nutrient availability, reduces nutrient loss, and ensures that the plants receive a steady supply of essential elements for healthy growth. Soil structure improvement. Cuba products can help improve soil structure, which is crucial for soil life. The organic matter and humic substances in Cuba Soil Conditioner can enhance soil aggregation, creating a porous soil structure. This improves water infiltration, root penetration, and air circulation within the soil. The improved soil structure provides habitats for soil organisms, allowing them to thrive and contribute to nutrient cycling and soil health. Pest and disease control. Cuba products may contain natural ingredients with pest and disease control properties, such as neem seed extracts. These natural compounds can help suppress soil-borne pests and pathogens that may harm sugarcane plants or the beneficial organisms in the soil. By reducing pest and disease pressure, Cuba products create a healthier environment for soil life to flourish. By promoting microbial activity, organic matter decomposition, nutrient cycling, soil structure improvement, and pest and disease control, Cuba products support a diverse and thriving soil ecosystem. This, in turn, provides a favorable environment for the growth of sugarcane plants, as the soil life contributes to nutrient availability, soil structure, and overall soil health. Root development. Cuba products play a vital role in supporting the development of healthy roots in sugarcane plants through various mechanisms. Nutrient supplementation. Cuba products are enriched with essential macro and micronutrients such as phosphorus, potassium, calcium, magnesium, and trace elements. These nutrients are crucial for root development and overall plant health. By delivering these nutrients directly to the roots, Cuba products ensure that sugarcane plants receive the necessary elements for optimal root growth and function. Soil health improvement. Cuba products focus on improving soil health, which indirectly benefits root development. Healthy soil provides a favorable environment for root growth, nutrient uptake, and water absorption. The organic carbon, humic acid, and other components present in Cuba products enhance soil structure, water holding capacity, and nutrient availability. This creates a conducive environment for robust root growth and development. Enhancement of microbial activity. Cuba products contain beneficial microorganisms such as trichoderma that enhance microbial activity in the soil. These beneficial soil microorganisms play a crucial role in promoting root health and nutrient cycling. They aid in the decomposition of organic matter, release nutrients in forms that plants can readily absorb, and protect roots from pathogenic microorganisms. By enhancing microbial activity, Cuba products indirectly support the health and vitality of sugarcane roots. Improved water retention. Cuba soil conditioner, with its hygroscopic nature, can absorb moisture from the air and release it to the plants as needed. This feature helps maintain adequate soil moisture levels, which are essential for root development and function. Enhanced water retention capacity ensures that sugarcane plant roots have access to a continuous water supply, promoting their growth and overall plant health. Disease and pest resistance. Cuba products, including Cuba Soil Booster, contain natural ingredients like neem seed and seaweed extracts that provide natural pest and disease control. These components help ward off pests and pathogens that may attack sugarcane roots. By protecting the roots from damage caused by pests and diseases, Cuba products contribute to the overall health and vigor of sugarcane plants. A well-developed root system also helps withstand wind pressure, reducing the risk of uprooting. In summary, Cuba products support root development in sugarcane plants through nutrient supplementation, improvement of soil health, enhancement of microbial activity, increased water retention capacity, and protection against pests and diseases. These combined effects promote the growth of healthy and robust roots, which are essential for the overall growth, productivity, and resilience of sugarcane plants. Growth of sugarcane stems. Nutrient supply. Cuba Soil Conditioner and Cuba Soil Booster contain a range of macro and micronutrients essential for plant growth, including phosphorus, potassium, calcium, magnesium, and trace elements. These nutrients are important for overall plant development, including stem growth. By providing a balanced and readily available nutrient supply, Cuba products ensure that the sugarcane plants have the necessary resources for robust stem growth. Hormone stimulation. Cuba products may contain organic compounds, such as amino acids and seaweed extracts, which can act as natural plant growth regulators or hormones. These substances can stimulate cell division, elongation, and differentiation in the stems of sugarcane plants. By promoting hormone activity, Cuba products can enhance stem growth and development. Enhanced root system. Cuba products, particularly Cuba soil conditioner, focus on improving soil health and root development. A strong and healthy root system is essential for efficient nutrient uptake and water absorption, which directly influences stem growth. By enhancing the root system through improved soil structure, increased microbial activity, and nutrient availability, Cuba products indirectly support the development of vigorous and well-developed stems in sugarcane plants. Stress reduction. Cuba products can help alleviate stress on sugarcane plants, which can positively impact stem growth. The organic components, such as humic acid and fulvic acid, present in Cuba products help improve the soil's water-holding capacity and moisture retention. This aids in maintaining optimal soil moisture levels, reducing water stress on the plants. Additionally, the presence of beneficial microorganisms in Cuba products enhances plant resilience to environmental stress factors, further supporting healthy stem growth. Disease resistance. Cuba products contain natural compounds with disease control properties, such as trichoderma. By suppressing soil-borne pathogens and promoting a healthier soil environment, Cuba products can help protect sugarcane plants from diseases that can impede stem growth. Disease resistance contributes to overall plant health and allows the stems to develop without hindrance. By providing essential nutrients, stimulating hormone activity, enhancing root systems, reducing stress, and improving disease resistance, Cuba products create favorable conditions for optimal stem growth in sugarcane plants. These factors collectively contribute to the development of sturdy, well-formed, and productive stems in sugarcane crops. Cuba soil conditioner incorporates a sustained release mechanism that offers several benefits to sugarcane plants. The sustained release mechanism refers to the controlled and gradual release of nutrients and organic matter into the soil over an extended period of time. This mechanism ensures that the nutrients are available to the plants consistently, supporting their growth and development throughout the crop cycle. Here's how the sustained release mechanism of Cuba soil conditioner helps sugarcane. Nutrient availability. Cuba soil conditioner contains essential nutrients like nitrogen N, phosphorus P, potassium K, and micronutrients. These nutrients are released slowly and steadily into the soil, ensuring a continuous supply for the sugarcane plants. This sustained nutrient availability supports the plant's metabolic processes, including photosynthesis, root development, and overall growth. Balanced nutrition. The sustained release mechanism of Cuba soil conditioner ensures a balanced supply of nutrients to the sugarcane plants. It helps prevent nutrient imbalances that can occur with the application of fast-release fertilizers. A balanced nutrient profile contributes to healthier plants, optimal growth, and improved yield potential. Soil microbial activity. Cuba soil conditioner also promotes the growth and activity of beneficial soil microorganisms. These microorganisms play a crucial role in nutrient cycling and soil health. The sustained release of organic matter and nutrients from Cuba soil conditioner supports the proliferation of beneficial microbes, which in turn enhance nutrient availability, soil structure, and overall soil health. Water holding capacity. The organic matter present in Cuba soil conditioner improves the soil's water holding capacity. It helps retain moisture in the root zone, reducing water stress on the sugarcane plants. Adequate soil moisture is essential for proper nutrient uptake, plant growth, and resilience to drought conditions. Long-lasting effects. The sustained release mechanism of Cuba soil conditioner provides long-lasting effects, reducing the frequency of fertilizer applications. This not only saves time and labor for farmers, but also contributes to sustainable agriculture practices by minimizing nutrient runoff and environmental impacts. Overall, the sustained release mechanism of Cuba soil conditioner ensures a consistent and balanced supply of nutrients to sugarcane plants, supports soil microbial activity, improves water holding capacity, and provides long-lasting effects. These factors collectively contribute to enhanced plant growth, improved soil health, and sustainable sugarcane farming practices. Leaf health. Nutrient supply. Cuba products, being rich in macro and micronutrients, provide essential elements that are vital for the proper functioning of leaves. Nutrients like nitrogen, phosphorus, potassium, calcium, magnesium, iron, and others play key roles in various physiological processes in leaves, such as chlorophyll synthesis, enzyme activation, and carbohydrate production. Enhanced chlorophyll production. Chlorophyll is the pigment responsible for capturing light energy during photosynthesis. Cuba products, with their nutrient content, can promote chlorophyll production, leading to healthier and greener leaves. Improved chlorophyll levels enhance the plant's ability to convert sunlight into energy and produce carbohydrates. Increased resistance to stress. Cuba products can boost the plant's natural defense mechanisms, making it more resilient to environmental stressors. This increased stress tolerance helps leaves cope better with adverse conditions like drought, heat, or pest attacks. Stimulated enzyme activity. Enzymes are essential for various biochemical processes in leaves, including the synthesis of carbohydrates, proteins, and other compounds. Cuba products may stimulate enzyme activity, leading to improved metabolic functions in leaves. Faster recovery from damage. In the event of damage or pest attacks, healthy plants supported by Cuba products have a better chance of recovering quickly. The nutrients and other bioactive compounds in Cuba products aid in cell repair and regeneration. Increased leaf size and surface area. Some Cuba products contain organic matter and substances like humic acid, which can enhance root and shoot growth. Larger leaves with increased surface area enable better light capture and, subsequently, more efficient photosynthesis. Improved water retention. Cuba products can improve the water holding capacity of the soil, ensuring a steady supply of moisture to plant roots. This, in turn, helps maintain proper leaf turgidity and prevents wilting, particularly during dry periods. Balanced hormonal levels. Some Cuba products contain natural plant growth regulators, including auxins, gibberellins, and cytokinins. These hormones play essential roles in leaf development, cell elongation, and tissue differentiation. By improving the health of leaves, Cuba products indirectly contribute to better plant growth, higher yields, and improved overall plant health. However, it's essential to use Cuba products in accordance with recommended application rates and practices to maximize their benefits and ensure safe and sustainable agricultural practices. Additionally, local conditions and specific crop requirements should be considered when using any agricultural inputs. Optimizing tiller density in sugarcane farming for maximum yields and biodiversity. In sugarcane farming, determining the ideal number of tillers per acre is crucial for achieving optimal yields and promoting biodiversity. A well-balanced tiller density ensures efficient resource utilization, disease resistance, and sustainable farming practices. This article explores the factors that influence tiller management, highlighting the importance of variety selection, plant spacing, desired yield, growing conditions, and field observations. By understanding the relationship between tiller density and crop health, sugarcane farmers can make informed decisions to maximize productivity and foster a healthy ecosystem. Variety selection and tiller capacity. Selecting the right sugarcane variety is the foundation of successful tiller management. Different varieties have varying tillering capacities, affecting the number of tillers produced per plant. Consult with agricultural experts or local extension services to identify varieties that suit the specific agro-climatic conditions of the region and align with desired yield goals. Plant spacing and tiller distribution. Plant spacing significantly influences tiller distribution within the field. Proper spacing ensures adequate sunlight penetration, airflow, and efficient nutrient distribution. Generally, minimum spacing ranges from 2 to 4 feet between rows and 8 to 12 inches between individual plants. Appropriate spacing encourages healthier tiller growth and reduces the risk of overcrowding. Desired yield and tiller density. The desired yield per acre is a fundamental factor in determining the optimal tiller density. A higher target yield may necessitate more tillers to support cane growth and maximize productivity. However, Finding the right balance is essential, as excessive tillers can lead to resource competition and hinder cane development. Adapting to local growing conditions. Local growing conditions play a pivotal role in tiller development. Factors such as climate, soil fertility, and water availability directly impact a sugarcane crop's overall vigor and tillering capacity. Farmers must adapt tiller management practices to suit their specific region, accounting for these variables. Regular field observations and adjustments. Consistent field observations are paramount to assessing plant health, growth, and tillering patterns. Monitoring the number of tillers per plant, their thickness, and overall vigor helps in fine-tuning tiller density in subsequent plantings. Farmers can adjust their practices based on these observations to optimize tiller management. Negative consequences of excessive tillers. Allowing excess tillers to grow can lead to several negative consequences. Competition for resources. Overcrowding of tillers intensifies competition for essential resources like nutrients, water, and sunlight, leading to stunted cane growth and reduced overall yield potential. Nutrient imbalance. A high number of tillers can strain the nutrient supply in the soil, causing nutrient deficiencies and imbalances that adversely affect plant health and productivity. Disease and pest vulnerability. Dense plant stands provide a favorable environment for the spread of diseases and pests. Limited airflow and increased humidity in crowded canopies create conditions conducive to disease development. Difficulty in harvesting. An abundance of tillers can complicate the harvesting process, making it more time-consuming and labor-intensive. Optimizing tiller density in sugarcane farming is a critical aspect of achieving maximum yields and fostering a healthy ecosystem. By carefully considering variety selection, plant spacing, desired yield, local growing conditions, and regular field observations, farmers can strike the right balance to promote sustainable and productive sugarcane cultivation. Adopting responsible tiller management practices contributes to both economic success and environmental stewardship in sugarcane farming. Overwatering. Reduced oxygen availability. Excessive water in the soil can lead to poor aeration and reduced oxygen availability in the root zone. Oxygen is vital for root respiration and nutrient uptake. Without sufficient oxygen, roots may become stressed, resulting in reduced root growth and function. Root health issues. Overwatering can lead to waterlogging, where the soil becomes saturated with water and lacks proper drainage. Waterlogged conditions impede root development and can lead to root suffocation and rot. Damaged roots are less efficient in absorbing nutrients and water, impacting overall plant health. Nutrient imbalances. Overwatering can cause leaching of nutrients from the root zone, washing away essential elements needed for plant growth. Excessive water can carry nutrients deep into the soil profile or out of the root zone, leading to nutrient imbalances and deficiencies. This can result in stunted growth, yellowing leaves, and reduced yield. Increased disease risk. Waterlogged conditions promote the growth of pathogens and create a favorable environment for the development of root diseases, such as root rot and fungal infections. Overwatered sugarcane farms are more susceptible to diseases, which can further hinder plant growth, reduce yield, and increase the need for chemical interventions. Reduced productivity. Overwatered sugarcane plants may exhibit reduced vigor, delayed maturity, and lower cane and sugar yields. Water stress, followed by excess water, can disrupt the plant's physiological processes and impact sugar accumulation in the stalks. Over time, the overall productivity and profitability of the sugarcane farm may decline. To avoid the negative consequences of overwatering, it is important for sugarcane farmers to implement proper irrigation practices. This includes monitoring soil moisture levels, understanding the crop's water requirements at different growth stages, and adjusting irrigation schedules accordingly. Efficient irrigation systems like drip irrigation or precision scheduling tools can help deliver the right amount of water directly to the root zone, minimizing water wastage and optimizing plant health and productivity. Climate variations. The vital role of healthy soil in mitigating the effects of water shortage or drought conditions. Kuba products offer numerous advantages to sugarcane plants during periods of water shortage or drought, especially when used in combination with organic farming practices. Together, they contribute to improved soil health and water retention, ensuring better crop resilience and growth. Here's how these two components work synergistically. Organic farming practices play a pivotal role in enhancing soil structure and water holding capacity. By emphasizing the use of organic materials like compost, manure, and cover crops, organic farming increases the soil's organic matter content. This enriched organic matter acts like a sponge, effectively absorbing and retaining moisture, thus reducing water runoff and making water more accessible to plants. Additionally, organic farming fosters the formation of stable soil aggregates, creating essential pore spaces that enhance water infiltration and storage, while minimizing surface runoff and soil erosion risks. Furthermore, organic farming practices lead to increased soil organic carbon content, which further enhances the soil's water holding capacity. Organic carbon serves as a reservoir for both nutrients and water, promoting soil moisture retention and minimizing water loss through evaporation. Additionally, the active and diverse soil microbial community, fostered by organic farming practices, contributes to improved soil structure, porosity, and water holding capacity. These beneficial soil microorganisms help with soil aggregation, organic matter decomposition, and nutrient cycling, ultimately improving the soil's ability to retain water and withstand drought conditions. Kuba products, such as Kuba Soil Conditioner and Kuba Soil Booster, complement these organic farming practices by providing additional benefits during water scarcity. Water retention and conservation. Kuba products possess hygroscopic properties, enabling them to absorb and retain moisture. During drought or water shortage, these products minimize water evaporation and enhance water infiltration and retention in the soil. This ensures that sugarcane plants have access to water for a more extended period, even when water resources are limited. Improved soil structure. Kuba products aid in improving soil structure by enhancing soil aggregation and reducing compaction. This leads to the formation of well-structured soil with increased pore spaces, facilitating better water penetration and root development. The improved soil structure enables efficient water utilization by the plants and helps them withstand water scarcity. Enhanced root growth and drought tolerance. Kuba products promote root growth and development, which is crucial for drought tolerance. By providing essential nutrients, organic carbon, and beneficial microorganisms, Kuba products support the growth of healthy and vigorous root systems. Well-developed roots can explore the soil profile for water, accessing deeper soil layers during drought conditions. Nutrient availability and plant health. Kuba products enhance nutrient retention and availability in the root zone, ensuring that the plants receive essential nutrients even during drought. This promotes overall plant health and resilience in water-scarce conditions. Improved plant stress tolerance. Kuba products contain organic compounds, such as humic acid and amino acids, which assist plants in tolerating drought stress. These compounds stimulate the production of stress-related proteins and antioxidants within the plant, protecting cellular structures and minimizing damage caused by drought-induced stress. Enhanced water use efficiency. Kuba products help improve the water use efficiency of sugarcane plants. They regulate stomatal opening, reducing water loss through transpiration. This enables the plants to conserve water and maintain better hydration, even in situations of limited water availability. Improved water use efficiency allows the plants to survive, grow, and develop during drought periods. While Kuba products provide significant benefits during drought or water shortage, it's essential to note that they should be used alongside appropriate water management strategies. Efficient irrigation practices, such as drip irrigation or mulching, should be implemented to optimize water use and minimize water loss. Furthermore, local environmental conditions and specific crop requirements should be considered when determining the appropriate application rate and frequency of Kuba products during drought situations. Visibly, organic farming practices can lead to observable changes in the soil, including darker soil color due to increased organic matter content. Improved soil structure characterized by well-formed aggregates and a crumbly texture. Increased earthworm activity and visible burrows. Improved soil moisture retention, resulting in a moister soil profile. Reduced soil erosion, visible as less runoff and sediment deposition. In summary, the combination of organic farming practices and Kuba products creates a holistic approach to improve soil health, water retention, and sugarcane plant resilience during periods of water shortage or drought. By adopting these practices, farmers can enhance their crop's ability to withstand water scarcity, mitigate the impacts of drought, and contribute to sustainable agriculture. Hot climatic condition. Kuba growth promoter and natural horticulture oil can provide several benefits to sugarcane plants in terms of extreme heat conditions. Here's how they can help. Enhanced water retention. Kuba soil conditioner and Kuba soil booster have hygroscopic properties, meaning they can absorb and retain moisture. In extreme heat, when water evaporates rapidly from the soil, Kuba products can help retain moisture in the root zone, preventing excessive drying of the soil. This improves the plant's access to water, even during periods of high evaporation, and helps prevent water stress. Improved soil structure. Organic farming practices encourage the formation of stable soil aggregates, which are vital for creating pore spaces in the soil. These pore spaces enhance water infiltration and storage, while reducing the risks of surface runoff and soil erosion. Kuba products also contribute to better soil structure by promoting soil aggregation and reducing soil compaction. This creates an ideal environment for root growth and development, allowing roots to efficiently absorb water from the soil. As a result, plants are better equipped to withstand heat stress and other adverse conditions. In summary, organic farming practices and the use of Kuba products work synergistically to enhance soil structure and water holding capacity. The increased organic matter content improves moisture retention, while the promotion of soil aggregation creates favorable conditions for root growth. This combination ultimately leads to healthier plants that can better cope with heat stress and thrive in challenging environments. Increased nutrient availability. Extreme heat can affect nutrient availability in the soil, as it can lead to increased nutrient leaching or hinder nutrient uptake by the plants. Kuba products, with their mineral composition and organic components, enhance nutrient retention and availability in the root zone. This ensures that the sugarcane plants have access to essential nutrients even under hot conditions, supporting their growth and productivity. Protection against heat stress. Kuba products offer protection against heat stress by containing organic compounds, such as humic acid and amino acids, which stimulate the production of heat shock proteins and antioxidants within plants. These compounds help protect cellular structures and minimize damage caused by heat stress. Additionally, the Kuba growth promoter, enriched with natural plant hormones and bioactive compounds, enhances plant resilience and stress tolerance by regulating growth processes and promoting efficient resource utilization. It aids in maintaining hormonal balance, enabling plants to withstand temperature extremes and other climatic stressors. By using Kuba products, farmers can help their plants cope with heat stress and improve their ability to adapt to varying climatic conditions. Regulation of plant transpiration. Kuba products contribute to the regulation of plant transpiration, particularly in extreme heat conditions, by improving water use efficiency and reducing water loss through transpiration. They achieve this by minimizing stomatal opening and transpiration rates, ensuring better plant hydration and preventing dehydration and wilting. The natural horticulture oil, a component of Kuba products, serves as a protective barrier for sugarcane plants, minimizing moisture loss during dry periods and excessive moisture during heavy rainfall. It also helps mitigate heat stress by reflecting sunlight and reducing temperature buildup on plant surfaces. Through the use of Kuba products, farmers can effectively manage plant transpiration and protect their sugarcane plants from the adverse effects of climatic variations. Overall plant health and vigor. By improving soil health, nutrient availability, and water retention, Kuba products contribute to the overall health and vigor of sugarcane plants. Healthy plants are generally more resilient and better able to withstand extreme heat stress. They can maintain metabolic activity, continue photosynthesis, and sustain growth and development even under challenging conditions. It's important to note that while Kuba products can provide benefits in terms of extreme heat, they are not a complete solution to counteract the effects of prolonged or excessively high temperatures. Additional measures such as proper irrigation management, shading, and other heat stress mitigation strategies should be considered to protect sugarcane crops during extreme heat events. Cold weather condition. Kuba products can provide certain benefits to sugarcane plants in cold weather conditions. While sugarcane is typically grown in tropical or subtropical regions, it can still face cold spells or frost events that can negatively impact plant health and yield. Here's how Kuba products may help in such situations. Frost protection. Higher sugar levels in plants, as facilitated by Kuba products, can provide a level of protection against frost damage. Sugars act as natural antifreeze agents, reducing the freezing point of plant tissues and minimizing cell damage during cold temperatures. Enhanced root growth. Kuba products promote root growth and development, which is essential for plant stability and nutrient uptake. A well-developed root system can help sugarcane plants better withstand cold stress by accessing deeper soil layers that may retain more warmth. Increased nutrient uptake. Kuba products contain macro and micronutrients, including minerals like calcium, potassium, and magnesium, which are important for overall plant health. Proper nutrient uptake and balanced nutrition can improve the plant's resilience to cold weather conditions. Improved plant vigor. The use of Kuba products enhances plant vigor and overall health. Healthy plants are generally better equipped to tolerate stress, including cold temperatures. They may have a stronger defense system and the ability to recover more effectively from environmental challenges. Microbial activity. Kuba products contain beneficial microorganisms, such as bacteria and fungi, that can enhance soil microbial activity. Healthy soil with active microbial populations can help break down organic matter, release nutrients, and improve soil structure. This, in turn, can provide better insulation for plant roots during cold weather. Sugarcane disease prevention and control measures. Red rot Colotatricum fulcatum. Red rot is a highly destructive fungal disease that infects sugarcane stalks, causing rotting, red discoloration, and wilting. Kuba Soil Conditioner and Kuba Soil Booster play a crucial role in enhancing overall plant health and strengthening the immune response. These products enable sugarcane plants to resist and recover from red rot infections. Furthermore, Kuba products containing beneficial microorganisms can effectively compete with the fungus and suppress its growth. Smut Sporosorium sitamonium. Smut is a fungal disease that affects sugarcane inflorescence and developing shoots, leading to the formation of black, powdery spore masses. Kuba products, with their nutrient supplementation and soil health improvement properties, enhance the vigor and resistance of sugarcane plants against smut. By improving plant health and nutrient uptake, Kuba products contribute to the plant's ability to withstand and recover from smut infections. Ratoon stunting disease Lefsonia xylem subsp. Xylem, ratoon stunting disease is caused by a bacterium that primarily affects the ratoon secondary shoots crop of sugarcane. It results in stunted growth, poor tillering, and reduced yields. Kuba products provide essential nutrients and promote beneficial microbial activity, thereby enhancing overall plant health and vigor. This can minimize the impact of ratoon stunting disease, improve tillering, and increase yields. Sugarcane mosaic virus. The sugarcane mosaic virus causes mosaic symptoms on the leaves, including yellowing, streaking, and mottling. While viral diseases like sugarcane mosaic virus are primarily managed through the use of virus-free planting material and insect vector control, Kuba products indirectly help reduce the impact of the virus by promoting plant vigor and overall health. Healthy plants are more resilient and better equipped to tolerate viral infections. Sugarcane grassy shoot phytoplasma. Grassy shoot is a phytoplasma disease transmitted by insect vectors. It causes the formation of multiple tillers, distorted growth, and grass-like shoots, leading to reduced yields in sugarcane. While insect vector control and removing infected plants are primary management strategies for phytoplasma diseases, Kuba products contribute to plant health and vigor. This indirectly supports sugarcane plants in recovering from the disease and maintaining productivity. Brown rust Buccinia melanocephala. Brown rust is a fungal disease that affects sugarcane leaves, resulting in rust-colored pustules, defoliation, reduced photosynthesis, and lower yields. Kuba products, with their focus on improving soil health and providing nutrient supplementation, promote overall plant health and vigor. Healthy plants are better equipped to resist and recover from diseases like brown rust. Additionally, foliar applications of Kuba growth promoter can enhance plant growth and bolster the natural defense mechanisms against rust pathogens. Furthermore, apart from diseases, sugarcane crops in India are vulnerable to the Eldana borer, an insect pest that causes significant damage. The borer's larvae tunnel into the stalks, leading to yield loss and weakened plants. Kuba products, particularly the natural horticulture oil with its insecticidal properties, aid in controlling and reducing the population of Eldana borers. Regular application of the oil, following recommended practices, helps effectively manage this pest. To ensure effective sugarcane disease management, it is crucial to adopt integrated disease management strategies. These strategies may involve practices such as crop rotation, utilizing resistant varieties, maintaining proper sanitation, and timely application of fungicides or other control measures. Local agricultural extension services and research institutions can provide specific recommendations and guidance tailored to the prevailing disease pressures in various sugarcane growing regions of India. It's important to note that the effectiveness of Kuba products in disease management may vary depending on factors such as the severity of the infestation and environmental conditions. Integrated disease management practices should be followed alongside the use of Kuba products for comprehensive disease control. Insect prevention and control measures. Sugarcane aphids Melanaphis saccari. Sugarcane aphids are small insects that feed on the sap of sugarcane plants. They can cause direct damage by sucking the plant's juices, leading to stunted growth, reduced yields, and even death in severe infestations. Aphids can also transmit viral diseases, further exacerbating the damage. Sugarcane early shoot borer Schiloinfuscatellus. The early shoot borer is a serious pest that attacks the early stages of sugarcane growth. The larvae tunnel into the young shoots, causing withering and wilting. The damage disrupts the plant's growth and reduces the number of viable shoots. Sugarcane top borer Sapophaga excerptalis. The top borer larvae feed on the growing points of sugarcane, leading to dead hearts in young plants. In mature plants, they bore into the internodes, causing whiteheads and weakening the stems. Sugarcane perilla Perilla purpusilla. Perilla is a sap-sucking insect that attacks sugarcane leaves. Large populations can lead to leaf drying and reduced photosynthesis, ultimately affecting the plant's overall health and productivity. Eldana borer Eldana saccharina. As mentioned earlier, the Eldana borer's larvae tunnel into sugarcane stalks, causing yield loss and weakening the plant's structure. Kuba products offer several mechanisms to help prevent and manage insect attacks on sugarcane. Natural horticulture oil. Kuba's natural horticulture oil acts as an insecticide by suffocating and disrupting the life cycle of many insects, including aphids, early shoot borers, and top borers. It forms a protective barrier on the plant's surface, preventing insect pests from feeding and laying eggs. Beneficial microorganisms. Some Kuba products contain beneficial microorganisms that promote the growth of a healthy rhizosphere root zone environment. A healthy rhizosphere attracts beneficial insects that can act as natural predators of pest species. These predatory insects, like ladybugs and parasitoid wasps, can help control aphid and perilla populations. Plant health enhancement. Kuba products, such as the soil conditioner and soil booster, contribute to overall plant health and vigor. Healthy plants are better equipped to withstand and recover from insect attacks. They also produce secondary metabolites and compounds that can act as natural repellents to certain insect pests. Nutrient supplementation. Proper nutrient supplementation with Kuba products ensures that sugarcane plants receive essential nutrients for robust growth. Healthy and well-nourished plants are less susceptible to insect infestations. Stress reduction. Kuba products can help reduce plant stress caused by environmental factors like drought or nutrient deficiencies. Stressed plants are more vulnerable to insect attacks, and by mitigating stress, Kuba products indirectly enhance the plant's ability to resist pests. Integrated Pest Management (IPM). Kuba products are part of an IPM approach, which emphasizes a combination of strategies to manage insect pests. IPM includes practices such as crop rotation, use of resistant varieties, biological control beneficial insects, and targeted pesticide applications when necessary. Kuba products fit into this approach by promoting a balanced ecosystem and supporting natural pest control methods. It's important to note that insect management in sugarcane requires a comprehensive approach that includes regular monitoring, proper sanitation, timely application of insecticides when necessary, and following recommended practices. Local agricultural experts and extension services can provide specific guidance on the optimal use of Kuba products for managing insect pests in sugarcane crops. While Kuba products can contribute to the overall health and vigor of sugarcane plants, it's important to note that achieving complete disease and insect freedom is a complex process that involves multiple factors. While Kuba products can enhance plant health and provide some level of protection against diseases and insect pests, they do not guarantee complete eradication of these issues. However, let's explore how Kuba products and certain plant characteristics can contribute to reducing disease and insect pressure. Enhanced plant health and immune response. Kuba products, such as the soil conditioner and soil booster, provide essential nutrients and promote beneficial microbial activity in the soil. These products help improve soil health, which in turn enhances the overall health and vigor of sugarcane plants. Healthy plants are better equipped to withstand diseases and insect attacks due to their stronger immune response. Increased plant vigor and resistance. Kuba products can enhance plant vigor, leading to stronger and more robust sugarcane plants. Such plants are less susceptible to diseases and insect pests because they have a higher capacity to resist attacks. Additionally, Kuba products containing beneficial microorganisms can compete with harmful pathogens and suppress their growth, further reducing disease incidence. Sugar levels and insect digestive system. Sugarcane contains high levels of sucrose, a type of sugar that plays a crucial role in the crop's commercial value. Insects, such as aphids and perilla, feed on sugarcane sap, which is rich in sucrose. When insects consume high amounts of sucrose, it can lead to osmotic imbalances in their digestive systems, affecting their ability to absorb nutrients and causing physiological stress. While Kuba products contribute to plant health, the high sugar levels in sugarcane sap can also act as a deterrent to certain insects, making them less likely to infest healthy plants. Indirect effects on insect population. Kuba products, particularly those containing natural horticulture oils, can have direct insecticidal effects on certain pests. These oils suffocate and disrupt the life cycle of insects by targeting their respiratory systems. By reducing the population of pests like aphids, early shoot borers, and top borers, Kuba products indirectly contribute to a lower risk of disease transmission and overall insect pressure on sugarcane plants. Integrated Pest Management (IPM) approach. Kuba products are part of an IPM strategy, which focuses on combining multiple pest management practices to reduce the reliance on chemical interventions. This approach includes practices like crop rotation, use of resistant varieties, biological control, and targeted pesticide applications when necessary. By incorporating Kuba products into an IPM program, farmers can promote a balanced ecosystem that supports natural pest control methods and minimizes the need for extensive pesticide use. It's important to emphasize that achieving disease and insect freedom in sugarcane crops is challenging, as it requires a comprehensive approach that addresses multiple factors. While Kuba products can contribute to plant health and reduce disease and insect pressure, they should be used in conjunction with other integrated management practices and regular monitoring to effectively manage diseases and pests in sugarcane crops. Local agricultural experts and extension services can provide specific guidance on the optimal use of Kuba products in accordance with local conditions and disease/insect pressures. The impact of sugar levels on sugarcane growth and health. Insights from Kuba products. Sugar levels play a crucial role in various aspects of sugarcane growth, including protein production, enzyme activity, sucrose accumulation, water retention, insect resistance, and overall plant health. Kuba products, such as the soil conditioner, soil booster, growth promoter, and horticulture oil, contribute to optimal sugar levels in sugarcane plants, leading to improved survival, pest immunity, and frost resistance. Monitoring sugar levels, achieving higher Brix readings, and maintaining mineral balance are essential for promoting plant health and productivity. Sugar levels in sugarcane plants have a profound influence on different aspects of growth and development, including protein production, enzyme activity, sucrose accumulation, water retention, insect resistance, and overall plant health. Kuba products, including the soil conditioner, soil booster, growth promoter, and horticulture oil, play a vital role in optimizing sugar levels and supporting the plant's well-being. Let's explore the relationship between sugar levels and various aspects of plant growth. Impact of sugar levels on plant survival and thriving. Below 2 Brix. Low sugar levels below 2 Brix indicate inadequate energy reserves, leading to reduced plant vigor and compromised chances of survival and growth. 2 to 6 Brix. Moderate sugar levels between 2 and 6 Brix contribute to improved plant health, nutrient utilization, and overall growth. 7 to 12 Brix. Optimal sugar levels between 7 and 12 Brix support the plant's chances of thriving, ensuring sufficient energy for vital processes and defense mechanisms. Sugar content and plant health. Water retention. Adequate sugar content enhances the plant's water retention capacity, enabling it to withstand drought conditions and minimize water stress. Insect resistance. Higher sugar levels in plants contribute to improved insect resistance, as pests like aphids, sucking insects, chewing insects, and grasshoppers are less attracted to high sugar tissues. Mineral balance. The mineral balance of plants influences their emission of different frequencies, which can affect insect attraction. Optimal mineral balance promotes healthy plant growth and reduces pest pressure. Achieving a Brix reading of 12 or higher. Plant pest immunity. Higher sugar content, reflected by a Brix reading of 12 or higher, contributes to reasonable plant pest immunity by making the tissues less favorable for pest feeding and reproduction. Frost protection. Sugars act as natural cryoprotectants, reducing the likelihood of frost damage and freezing in plants with higher sugar content. Brix readings throughout the sucrose accumulation stage and nutrient monitoring. Brix readings may fluctuate throughout the plant's life cycle, including the sucrose accumulation stage. Regular monitoring helps identify changes in sugar levels and adjust nutrient management accordingly. Nutrient ratios. Maintaining appropriate nutrient ratios, particularly nitrogen and potassium, supports optimal sugar production and prevents a drop in Brix readings. Maintaining proper nutrient ratios, especially the balance between nitrogen and potassium, is crucial for maximizing sugar production and preventing a decline in Brix readings. Supplementing these nutrient ratios with mineral-based fertilizers ensures a consistent supply of nutrients to the plants, while also supporting a healthy soil ecosystem. Proper nutrient ratios play a key role in the growth and development of sugarcane plants. Nitrogen is essential for vegetative growth and biomass production, while potassium is involved in sugar accumulation and overall plant health. Imbalances in these nutrient ratios can negatively impact sugar production and the quality of the harvested crop. In addition to supplying nutrients, it is important to consider the overall health of the soil ecosystem. Proper soil life, including beneficial microorganisms and organic matter, contributes to nutrient availability and uptake by the plants. By promoting a thriving soil ecosystem, the mineral-based fertilizers can work synergistically with the soil organisms, enhancing nutrient cycling and improving the overall health of the soil. By maintaining appropriate nutrient ratios and utilizing mineral-based fertilizers, sugarcane farmers can support optimal sugar production and prevent a decline in Brix readings. However, it is essential to carefully monitor and assess the nutrient requirements of the plants, soil conditions, and other factors to ensure the precise application of fertilizers and maintain a balanced and sustainable nutrient management approach. Consequences of lower sugar conditions. Protein production. Lower sugar conditions can negatively impact protein production, leading to reduced enzymatic activity and impaired growth. Enzyme activity. Insufficient sugar levels can hinder enzyme activity, affecting various metabolic processes necessary for plant development and overall life cycle. In conclusion, sugar levels in sugarcane plants have significant implications for protein production, enzyme activity, sucrose accumulation, water retention, insect resistance, and overall plant health. Kuba products, such as the soil conditioner, soil booster, growth promoter, and horticulture oil, contribute to optimal sugar levels and support the plant's survival, pest immunity, frost resistance, and overall growth. Monitoring sugar levels, achieving higher Brix readings, and maintaining a balanced mineral profile are crucial for promoting plant health and productivity in sugarcane cultivation. Detailed information specifically for striga and other invasive plants, weeds, and companion plants is available on our website and YouTube channel. Enhancing biodiversity in sugarcane farming with Kuba products and companion plants. Kuba products offer specific benefits for promoting biodiversity in sugarcane farming. These products improve soil health, attract beneficial insects, and reduce the reliance on chemical inputs. Additionally, incorporating companion plants, such as nitrogen-fixing and carbon-fixing plants, further enhances biodiversity. Here, we provide a list of recommended companion plants for promoting nitrogen and carbon fixation, as well as beneficial border plants suitable for sugarcane farming in India. Kuba products, combined with the use of companion plants, contribute to enhancing biodiversity in sugarcane farming. Let's explore the benefits of Kuba products in promoting biodiversity and the recommended companion plants for nitrogen and carbon fixation. Benefits of Kuba products for biodiversity, soil health. Kuba soil conditioner and soil booster improve soil health by enhancing soil structure, nutrient availability, and microbial activity. This creates a favorable environment for beneficial soil organisms, promoting biodiversity below ground. Beneficial insects. Kuba growth promoter and horticulture oil support the growth of beneficial insects by providing habitat and food sources. These insects act as natural predators, controlling pest populations and maintaining a balanced ecosystem. Reduced chemical inputs. By reducing the reliance on chemical inputs such as synthetic fertilizers and pesticides, Kuba products help preserve biodiversity by minimizing the negative impacts of chemicals on beneficial organisms. Companion plants for nitrogen and carbon fixation. Companion plants play a crucial role in promoting nitrogen fixation and carbon sequestration, contributing to overall biodiversity and soil fertility. Here are some recommended companion plants for sugarcane farming in India. Leguminous plants. Legumes like pigeon pea Cajanus cajan, cowpea Vigna unguiculata, and Lablabin Lablab purpureus are excellent choices for nitrogen fixation. These plants have a symbiotic relationship with nitrogen-fixing bacteria, enriching the soil with available nitrogen for sugarcane and other crops. Grasses and cover crops. Grasses like vetiver grass Chrysopogon zizanoides and cover crops like sun hemp Crotalaria juncea contribute to carbon fixation and organic matter addition to the soil. They also provide habitat and shelter for beneficial insects. Insect control crops for sugarcane. Marigold tagetes spp, chilies, garlic, and black mustard can help control pests in sugarcane fields. Disease control crops for sugarcane. Mustard Brassica juncea and Castor Ricinus communis can assist in managing diseases in sugarcane. Beneficial border plants in India. Planting beneficial border plants around sugarcane fields helps attract beneficial insects, provide nectar sources, and enhance biodiversity. Here are some recommended border plants suitable for India. Lucina leucocephala, vetiver grass Chrysopogons zizanoides, Gliricidia sepium, Agave spp, Cassia spp, Sesbania spp, Bambusa spp, Tephrasia spp, Nematodoracta indica. These border plants provide additional habitat for beneficial insects, support pollinators, and contribute to a diverse and healthy ecosystem. By incorporating Cuba products and companion plants, sugarcane farmers can enhance biodiversity, improve soil health, and reduce the reliance on chemical inputs. This holistic approach promotes sustainable and environmentally friendly sugarcane farming practices. Sugarcane growth cycle. Germination. The germination phase begins when sugarcane seeds or sets are planted in the soil. Sets are sections of the sugarcane stalk that contain buds capable of sprouting into new plants. During this phase, the buds in the sets start to grow and develop into shoots. Tillering. In the tillering phase, the shoots that emerged from the sets grow and produce additional shoots called tillers. Tillers are side shoots that emerge from the base of the main stalk. This phase is important for the formation of a healthy and dense sugarcane stand. Grand growth. The grand growth phase is characterized by rapid vegetative growth. During this phase, the sugarcane plants develop a thick, fibrous root system and elongate their stalks. The main objective of this phase is to establish a strong and healthy canopy of leaves, which is essential for photosynthesis and sugar production. Internode development. In the internode development phase, the sugarcane plants continue to elongate their stalks, and the internodes, the sections between the nodes, start to differentiate. This phase is crucial for determining the length and quality of the sugarcane stalks. Panicle initiation and flowering. During this phase, the sugarcane plants start to develop inflorescences known as panicles. However, in commercial sugarcane cultivation, flowering is undesirable as it negatively affects sugar content and plant vigor. Most commercial sugarcane varieties are bred to be sterile and do not produce viable seeds. Maturity and harvest. The maturity phase is reached when the sugarcane plants have accumulated sufficient sugar content in their stalks. The exact timing of maturity depends on the variety and the desired sugar content for harvesting. Cuba products can support sugarcane plants throughout these different phases by promoting overall plant health and soil fertility. Some of the ways Cuba products can help include enhancing soil health. Cuba products such as the soil conditioner and soil booster improve soil structure, nutrient availability, and microbial activity. This creates a favorable growing environment for sugarcane plants, enabling better root development, nutrient uptake, and overall plant health. Providing essential nutrients. Cuba products contain nutrient supplementation that can support the nutritional needs of sugarcane plants throughout their growth stages. These essential nutrients help promote healthy growth, increased vigor, and improved sugar accumulation in the stalks. Strengthening plant immunity. Cuba products, particularly those containing beneficial microorganisms, can enhance the plant's natural defense mechanisms. They stimulate the production of defense compounds and strengthen the plant's immune response, making it more resilient to diseases and pests that can affect different phases of growth. Optimizing growth and yield. By improving soil health, nutrient availability, and plant vigor, Cuba products contribute to optimal growth and development of sugarcane plants. This, in turn, can result in higher yields, better quality stalks, and increased sugar content. Reducing stress and improving drought tolerance. Cuba products can enhance the plant's ability to withstand environmental stresses, such as drought. By improving water retention in the soil and promoting efficient water use by the plants, Cuba products help mitigate the negative impacts of water stress on sugarcane growth and development. It's important to note that the specific application methods and timing of Cuba products may vary depending on the sugarcane variety, local conditions, and recommendations from agricultural experts. Farmers should consult with local agricultural extension services or agronomists to determine the best practices for incorporating Cuba products into their sugarcane cultivation practices at each growth phase.